Okay, here's a multiple regression model. We're going to try to show interaction. So this little story is about UFOs and aliens, right? Our criterion variable is going to be the annual number of reported UFO sightings. We're going to try to make a predictive model. So hold on. So multiple regression, interaction. This is going to be a lesson on this stuff, okay? Information from 97 U.S. cities has been collected. And here's the data. I'll just show you the data. Okay. So there are three predictors, one criterion. And we labeled them thusly. Predictor 1 is the population in thousands of the city. Predictor 2 is what percent of the population are living in rural areas. That means away from the city. Predictor 3 is how many cubic feet of water the city has, usually in open containers like lakes or rivers or dams. And that's in millions of cubic feet. And what we're trying to predict is the outcome, or the criterion, or the DV, is the number of reported UF sightings a city will have. Step 1, you're going to run a simultaneous multiple regression with your predictors and your criterion to check the assumptions of the data. So what were the assumptions again of a multiple regression? Normality, always normality, autocorrelation, linearity, homoscedasticity, last but not least, multicollinearity. So we're going to address these assumptions one at a time. So normality. How do we find normality with multiple regression models? Let's show you how in SPSS. But before that, I forgot to cut and paste the data in there. So I'm going to go ahead and just cut and paste the data into from the Excel spreadsheet into the SPSS sheet. Please hold. So I'm going to name the variables real quick. All right, there's our names. Don't forget to change the scales into scales. Right, they're all scales. And I believe we're ready to go. All right, once you have your data in your SPSS, you're going to go to Analyze, Regression, Linear. Our DV are UFO sightings. Our IVs are the other three. All right, statistics. We need to check Durbin-Watson. That's our autocorrelation. We want our descriptives. We're going to need the means. Collinearity, that's one of the assumptions as well. Click Continue. Next, we're going to plots. This will check our homoscedasticity, right? The predicted is always your X. The residual is always your Y. And we might as well check the histogram. That's going to make a histogram of the residuals. That will tell us if the data is normal as well. Click Continue. Last but not least, we're going to do the Mahalanobis. Right? That's going to tell us if we have any outlier residuals. Okay, and that's Continue. Click OK. Okay, we're going to look at the output sheet and address the assumptions in different particular orders. So the first box here, there's the means of our data. Okay, we're going to need the means of the IVs, of the predictors, in order to create our centered terms. So we really need this information. Okay, next box, correlations don't care. Durbin-Watson, that's what tells us if our autocorrelation has been violated, and it has not. Okay, this number is very comfortably between 1.5 and 2.5. All right, next assumption is collinearity. And again, we did not violate collinearity, multicollinearity, because the tolerance is greater than 0.1 and the VIF is less than 10. So we did not violate collinearity. Now we're going to use the Mahalanobis maximum value here, 13.459. So that is from our data. Let's check on the Mahalanobis critical value data sheet. Let me pull that up real quick. All right, and this spreadsheet should be on our Moodle somewhere, so look around. So our alpha is always 0.05. Our sample size in this problem was 97. And the number of IVs was 3. Hit enter. Bam. So we did not go over this critical Mahalanobis distance. Therefore, we do not have any residuals that would be considered outliers. So in other words, the data is relatively normal. All right, we can also check our homoscedasticity by going down to our graph. This one says that the residuals are relatively normal, which we kind of knew that already.
Evenly distributed. So you can just say, let's just draw the lowest line to make this faster and faster and faster.
Are you done? Okay, we're going to check the homoscedasticity of the scatter plot of the residuals. You're going to double click on it, and we're just going to add the lowest line right off the bat, okay? The lowest line hopefully will be relatively horizontal. If it's not, that means that we may have violated the assumption of homoscedasticity, and there it is. And again, it looks like we might have minorly violated the assumption of homoscedasticity. It is not a flat line, but it never is. It's never perfect. But I'm going to say that it may have been minorly violated, but not enough to stop the test. So we're going to go ahead and check the last assumption of linearity next. All right, last one is to check is the linearity, and that's the linearity between each of the IVs and the DV. So let's get back to our SPSS. What we're going to do is go to Graph, Legacy, Scatter Plot. I might be going kind of fast here. We've done these exact same things in several of the previous videos, so I'm hoping you got this down already. But we're taking a simple scatter plot, and we're going to define it. So our DV is UFO sightings. That's our y-axis. And we're going to start with population. And that's all we need for the first one. So we're going to click on that. And we're going to add the best fit trend line right there. Linear. So if this has a 0 regression, that means we violated the assumption of linearity. But that is not 0. It's close to 0, but it's not 0. So the first IV, linearity, has not been violated. Let's move to the second one. Graphs. Scatter. Simple. Define. We're simply going to switch the IVs real quick. So the next one is rural percentage. Rural percentage. Click OK. So let's add our best fit line. It's in there. Close. Okay, that is obviously not 0. So again, the second IV and the DV did not violate linearity. Last one. Okay, let's bring it back into graphs. Graphs, legacy, scatter plot, scatter dot, simple, define. We're going to kick out our rural. And which one didn't we do yet? Water. So water. And then we click OK. Here is the last linearity check for water and UFO sightings. And again, that is not 0. So we did not violate any of the assumptions of linearity. So now it's finally time to run the simultaneous multiple regression model to see if it's significant or not. And then we'll decide from there whether we should check for interaction or not. So hold on. Now it's time to run the simultaneous multiple regression to see that, first of all, if it's a significant regression, or if it's strong, or if you want to make it stronger. So let's go ahead and do that next. So one simultaneous multiple regression coming up. You're going to go to Analyze. You're going to go to Regression. You're going to go to Linear. Okay, we cleared this out. But the DV is the number of sightings. The IVs are population percentage in water. We're going to unclick a lot of stuff and re-click a lot of stuff. All right, we've already checked assumptions, so we're not going to do the Durbin-Watson. We're not going to do the collinearity. Descriptives we've already done before. I'm going to click it again. We're going to need that when we center our variables. And we are basically good to go to run this regression. So we're just going to click on it and interpret the outputs to see if it's significant or not. So let me line this up. So there's our means again. And this is our R squared, right? 0.31, which means about 31% of the variance in the DV, in the number of UFO sightings, can be accredited to this model. And the ANOVA tells us that we do have a significant regression, okay? So we do have a strong model, but now we're going to try to make it better. We're going to try to make it more stronger by checking the interaction. Please hold. But before we check for interaction, we need to look at the original model to see if any of the predictors are significant influencers of the DV. So we're looking at population first, not significant. Rural percentage is significant, okay? Water is not significant. So the only significant predictor is rural percentage of the population living in outside the city, okay? So that is a significant predictor by itself. If it's a significant predictor, it cannot be a moderator, okay? So rural is our significant predictor. All right, this is where we check for interaction between the predictors in a multiple regression model. Step 3, centering. All right, real briefly, centering, you only use it on your IVs in a multiple regression model, only on the predictors, okay, and they have to be continuous variables. But how you create, what centering is you take each individual subject, each score in each of the IVs, you subtract it from that IV's mean, okay? So this is what we call the centered term. I'll say it again. You take each subject, subtract the group mean, the IV mean there, and the difference between the two will be the centered term of that variable. Back to SPSS, and we'll show you how to center. Okay, you're going to go to transform, compute variable. So the first one, I'm just going to call it center population, pop. So this is the naming box. So that's going to be the name of the centered variable. What I'm going to do is I'm going to take the population, bounce it over here. I'm going to hit the subtraction, and then I'm going to subtract the mean.
We already paused, okay.
Hold on while I go get the means. There they are. I'm going to go ahead and write them down. Hold on. Okay, back. So the population mean was 141.5. I'm going to click OK. So we just created a new variable, okay, a centered variable. Part 2, we're going to do it for all 3 of them. Compute variable. This one I want center, we'll call it rural. Great. Delete that. You're going to take your rural percentage minus the mean of 13.1. Okay. Last one, transform, compute. This will be center, and I'll just call it water. And we'll delete that. So we're going to put water, subtracting its mean of 55.0. Click OK. I always double check the data to make sure we have 3 new centered variables, right? Leave nothing to chance. And you're going to actually click the data view. You want to look at the data. Here they are. The centered population, rural, and water. Okay, so now we have to make the interaction terms. Hold on. All right, so now we have the 3 centered predictor variables. Centered terms. Now it's up to step 4. We have to create our interaction terms. And how you do that is we multiply the new centered terms. I'll show you how to do that in SPSS. Please hold. Go to transform, go to compute variable. Clear everything out, hit the reset button down here. Okay, so this is going to be an interaction term. So you have to have every pairwise combination of all possible predictors, and the last one is all predictors in the same lump. So let's take, we're going to take population mixed with rural. Okay, that's the naming box again. So this is our interaction term name. So what I'm going to do is I'm going to put the centered population asterisk the centered rural. Bump that in there. Okay, that is a new term. It's a new variable that is going to check for interaction between those two predictors. So I'll show you again with a different one. We're going to hit reset on the bottom down here. So the next one I'm going to make population and water. That's the name of it. So I'm going to take my centered pop, asterisk, centered water, bump it over to the box, click OK. So that's a second interaction term that we're going to check for. Repeating, compute, reset. This one is going to be water and rural. And that should have been the third and last comparison. Again, this is just the name of it. So I'm going to put my center water into the box, asterisk, center rural into the box, click OK. Again, I should have 3 new variables. Oh, wait, almost forgot. I got one more. Transform, compute. It has to be all 3 of them. So I'm going to name it water, rural, and pop. Right, those are my 3 IVs. And then I'm going to hit asterisk, and then my centered population in there. You see, so that's looking for the interaction between all 3 IVs. Click OK. All right, I'm going to check to see that the new interaction terms were created. Right, I went back to the variable view here. And let me scroll over. Yeah, they're all here. Right. The previous ones were the centered variables. But remember, we use the centered variables. We multiply them together to create the interaction. So this is the interaction term between population and rural percentages, population and water acreage. Then this one is water and rural percentage, and this last one is all 3, okay? So these numbers are interaction numbers. Their units don't mean anything. But we're going to go ahead and use them to see if we can't build a stronger multiple regression model. So here we go. Here comes the fun stuff. Step 5. We're going to run the multiple regression again. This time we're going to use the centered terms and the interaction terms. So here we go. We're going to go to Analyze, Regression, Linear. Okay, we're taking out the regular variables. Sorry, the regular predictors. We're going to put in the 3 centered variables first. Those are going to be our IVs. We're going to click Next. We're going to stick in the first interaction term. That's your pop rural. Click it into the box. Next. Our second interaction term, pop water. Pop water. Next. Our third one is water rural. Click it into the box. Next. Our last one is all 3 interaction term. Click Next. Do not click Next again because we're done entering them into different orders. Go to the statistics box. Now we're going to check the R-squared change. Okay, that's going to tell us if the different models, if the R-squared is going to change. That will be proof that you have interaction somewhere going on. Well, we'll walk you through that as we go. But now remember, we don't need to do the Durbin-Watson. We already did it. We don't need collinearity. We already did it. Okay, so we're just gonna run the multiple regression model with the new terms. So I'm going to click Continue. Okay. So here's our new multiple regression output. There's the means of all our new data. But remember, these interaction terms, the units are all messed up. Do not worry about them. Don't look at the correlations at this point in time. And here's your 5 different models, right? Okay, I'll explain them as you go. Your first model was just with the centered terms. Second model were the centered plus the first interaction term, plus the second interaction term, plus the third interaction term, plus the fourth interaction term. That's where you get 5 different models. But here is your golden box right here. Okay, we ran the model. Let's go to step 6. So now we have to look for a significant R-squared change between the different model regressions. Okay, so what it did first was it ran the regressions with the 3 centered terms. The second model it ran was with the first interaction term. The third model, it added another interaction term. So every time we add an interaction term, it reruns a new model. So we have to look for the change in the R-squared between the models. That will indicate that there was some kind of significant interaction going on. So please hold. So back to our box, model summary box. The first model, we already knew it was significant. Okay, that was with the original terms. We should get the same results with the centered terms, and we did. Okay, so here's the one where the first interaction, we're checking between, looks like the population and the rural percentages. You go over here to the significant F change, not quite. If this was less than 0.05, then you could say there was interaction going on between those two predictors. So there was no interaction for the second model. There was no interaction for the third model, but there was interaction for the fourth model. So the fourth model was when we added the water and the percentage of rural people. Interesting. So what this tells me is that there is some kind of significant interaction going on between the percentage of rural population and how much water a city has when it comes to predicting the UFO reported sightings. Isn't that amazing? And then the last one is there was no interaction between all three, but we still have interaction between, again, the amount of water a city has and what percent of its population is rural. All right, so now I'm going to go down and check the beta weights real quick. Looking at the coefficients box, the beta weights, that's what we're going to go by. And I'm going to move it up just a little bit so we can see this fourth model box. That's the only one that was significant. So according to the beta weights, the rural, the centered rural, is huge. It's a huge, good predictor of the number of UFO sightings, and it's a negative one. So in other words, the more people that live in the rural parts, the less UFO sightings they're going to have. And the other significant beta weight is this last one right here, okay? Water and rural. That's the interaction that we're looking for. So besides the main predictor of the rural variable, it's looking to me like water could be a possible moderator. So let's go ahead and look into that. All right, step 7. You're going to list all possible moderators. So let's take a quick look at our box of gold here. So you'll remember from the original simultaneous multiple regression model, right, the regular predictors before we centered them or anything, whichever one has the largest beta weight, that's going to be a predictor. Okay, so in our original model, the percentage of rural population was obviously a main predictor of this model. So if a predictor variable is a main predictor, it cannot be a moderator. Okay, so remember that. So rural percentage is the main predictor. So let's look at the interaction to see if there's a moderator working with the rural percentage. So hold on. All right, so here's the coefficients with the centered and the interaction terms. So remember, the main predictor is rural, so it cannot be a moderator. But let's look at our significant model here. That was number 4. Let me pull it up a bit. And again, I'm going to look at the significance value. The only one that is significant is the interaction term between water and rural. So what this is telling me that is water is the moderator. Okay, I'll say that again. Water is acting like a moderator. Step 8. Now that we know which interaction is significant, we're going to rerun the regression using just the center terms and those significant interaction terms. That's going to give us a much more accurate R-squared. Those will be the unstandardized B weights that we'll use for our regression terms. So let's knock this puppy out. Analyze, regression, linear. I'm going to reset it so we don't get something we don't need. But UFO sightings is our DV. We got our 3 centered terms as our IVs. And then we're just going to throw in the water rural for next. Water rural for the next, okay? And then we're just going to hit OK. And again, the data that's showing up now should be a lot more accurate. It might not be as strong, but it's a lot more accurate. Okay, so this is the finished model. It looks to me like the R squared with the interaction term it's up to 0.365, which is a little bit stronger than the other one. So all right, we've just finished this, step 8. Let's move on to step 9. Now we will write out the regression equation using those final unstandardized B weights. So hold on while we pull those up. All right, here's the coefficients from the finalized model, the one we just ran. So again, we're going to look at the unstandardized B weights, the coefficients, to write out the prediction model as a mathematical equation. And remember, we're going to use the second model because that's the one that contains the interaction. So here are your coefficients. Give me 1 second while I transfer them over. All right, so here we go. X1 is the population variable. X2 is the percentage of the population that's rural variable. X3 is the cubic water variable. And this one, X2 times X3, that's an interaction term. Again, we're just pulling off the unstandardized B weights from the SPSS from our final regression model, the one with interaction. And this is what we get. Okay, let me show you those terms again. Right? These are the beta weights, or I'm sorry, these are the B weights we're using in this regression model. Okay? So there's your model itself, and it's a pretty strong model. Remember, it's got about a 36% variance explanation rate. So step 10 is interpret the results in words of English. So interpreting the results from the final regression model would be the number one predictor for UFO sightings for the cities would be the percentage of the rural population. In other words, the higher percentage you have of people living in the rural areas, the lower number of sightings you're going to have. And then what's also working together with that predictor, with the rural predictor, is your water predictor. So in other words, the more water a city has, the more UFO sightings you're going to have. Okay, and that is your prediction model in a nutshell. Okay, co-pilot, thank you for reminding Matt. So and you also have to write up the APA results. Okay, so what you're going to write up in your APA are the following: your assumptions, whether they were violated or not; your simultaneous results, your original R squared, whether it was significant or not; if you can identify a main predictor from your original simultaneous multiple regression, okay? Was there a significant interaction or not? If there was any kind of significant R squared changes when you started adding those interaction terms into the models. Can you identify a moderator? And then after you've identified the moderator, you can write your prediction equation. And then you should also try to put it in plain English. You know, what do the variables tell about each other? That's it in APA formatting. So there's one more step. And that's step 11. And it's kabam! You're done. Okay, this was a long video, but if you can get this, I'm very, very proud of you. MGZ and co-pilot. Out.
Of course.
Just means outtakes.
Are you recording this?
I am recording this. All right, we're done with step 4. We created all the terms we need. God bless America.